All right, we mentioned reference angles in the last video, and now we're going to define them and look at several examples. The reference angle of theta is the smallest angular distance between the terminal side of theta and the x-axis. Now, that is one of the most common mistakes people make, is drawing to the y-axis instead of the x-axis, because sometimes the y-axis is closer, but reference angle always goes back to the x-axis. And I denote the reference angle of theta by theta sub ref. So let's look at some examples here. I've got 6 examples where we're just finding the reference angles of a bunch of things. So the reference angle of 120 degrees. Now I'm going to first label this. This is 0, 90 degrees, 180, and 270. So let's see, we're supposed to draw 120 degrees. That's going to be between, it's going to be in this quadrant over here, between 90 and 180. It's going to be closer to 90. It's supposed to be like a third of the way down, I guess. So 120 is right here. Here's my angle. All I'm going to do is draw the terminal side. So that's the angle. And the reference angle is here. And so the reference angle is going to be the distance from 120 to 180. So the reference angle is 60 degrees. All right, 205 degrees. That's going to be between 180 and 270. And so it's going to be down here somewhere. All right, so 180 up to 205. What's the difference there? It's the difference is going to be 25 degrees. So that's this angular distance here. Maybe over here I should mention this was 180 degrees minus 120. All right, now this next one, 280 degrees. Well, at the bottom down here we've got 270. So that's going to be 10 degrees beyond 270. So that's going to be here. 280. All right, but remember, reference angle is always the angle up to the x-axis, and it's always the smaller. You wouldn't go around back over there. You take the smaller route, the shortest route to the x-axis. So this is going to be an angle of, well, this was 0, but it's also 360 degrees. So you do, for this one, you do 360 minus 280, which should leave you with 80 degrees. This is my reference angle. Now notice sometimes you don't try to memorize anything about subtract from or add to or whatever. Just draw the picture and come up with what that distance is there. All right, we got 3 more examples, and these are doing the exact same thing, except now we're doing it in radians instead of degrees. So let's see, 11 pi over 6. I'm going to go through here and label my first one. This is 0. Up top, this is pi over 2. Then this is pi, radians. Then down here, this is 3 pi over 2. And we got to figure out where 11 pi over 6 goes on here. So here's what I would do. Instead of leaving this as pi over 2, let's write it as 3 pi over 6. Let's write this as 6 pi over 6. And this would be 3/2, multiply the top and bottom. You get, by 3, you get 9 pi over 6. And I'm going to count around on this thing kind of like it's a clock. We're supposed to go to 11 pi over 6, so that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11 pi over 6 right there. let's see. What about the 0? Well, that's also 2 pi. Or 2 pi would be 12 pi over 6. So I would do that and come up with 11 pi over 6 is right here. So my reference angle is going to be this bit here. And what is that difference? Well, it's the difference from here to here. So 11 pi over 6 to 12 pi over 6. Reference angle there is pi over 6. All right, let's do the next example. 7 pi over 12. Now I'm going to do the same thing I did on the previous one. I'm going to go through here and label this. 0, this is pi over 2, but tell you what, let's don't even label it with pi over 2. It's a half pi, which is 6 pi's over 12. This one is pi, which is 12 pi over 12. So if you think about this, it's like we're looking at pi over 12 chunks, or we're dividing this up into chunks of size pi over 12. All right, so if I start here, this is like 1, 2, 3, 4, 5, 6. Like each one of these tick marks is a 12th of pi. And so you get up here to 1, 2, 3, 4, 5, 6 pi over 12. The next one is going to be 7 pi over 12. So what's my reference angle? It's this down here. Now I could go in and say 12 pi over 12 minus 7 pi over 12 gives you a reference angle of 5 pi over 12. Or you could count it out. This is 7 pi over 12, so 8, 9, 10, 11, 12. 1, 2, 3, 4, 5 pi over 12. All right, let's look at this one. 5 pi over 6. All right, whoops. Got 0 here. Up here, this is pi over 2, or 3 pi over 6. This is pi, well, this is pi. And I could write pi as 6 pi over 6. So I'm supposed to go 5 pi over 6. So that's going to be 5/6 of the way over here. Our reference angle is going to be right here. I should draw that where it actually looks like an angle instead of a line. So my reference angle here is pi over 6. So on all of these examples, what we're doing is we're finding the smallest angular distance back to the x-axis, and that is our reference angle. All right, I want to talk about using reference angles, and we'll do that in the next video.